Hello everyone, and welcome to Biopedia. At A-level biology, we were always taught that dominant versus recessive phenotypes are inherited in the 3-to-1 ratio if both parents are heterozygous. This is because, if both parents provide a big A and a little a allele, 3 out of every 4 offspring will carry at least one dominant allele. I'll hopefully be able to supplement this episode with a blog post on Punnett squares over at our website for those of you who would like a refresher on this. However, this ratio can be skewed by the phenomenon we're going to discuss today, lethal alleles. These were first discovered in the early 1900s by Lucien Queneau, who found one of these alleles in mice. In mice, yellow coat colour is determined by the dominant allele. However, if a mouse embryo ends up homozygous dominant, it doesn't survive to be born. A similar example crops up in Manx cats which do not have a tail. This tailless condition is dominant from a genetic point of view, meaning that any cat which has only one taillessness allele or two doesn't have a tail. However, being homozygous dominant with 2 copies is, once again, fatal. This isn't just restricted to the animal world. A paper from 2015 detailed that, on average, each human autosome will have 0.29 lethal recessive alleles, which will be fatal when and if an individual is homozygous recessive. Apparently, average numbers of these recessive mutations also stays relatively the same between different eukaryotes, even among organisms which have very different genome sizes. Gao et al. 2015 also detailed that the number of recessive mutations like this, and how serious they are, can influence how severe the effect of inbreeding is, showing their application in the real world as well. However, having a lethal allele doesn't automatically mean death without reproduction. For example, Huntingdon's disease, which is caused by a dominant allele, is fatal, with the 2 most frequent causes of death being cited in one paper as pneumonia and suicide. However, this fatality occurs later in life, after reproduction can have already happened, in contrast with our discussion of mouse pigment alleles where the mice died before even being born. This later appearance of negative effects allows the allele to be propagated in the population even though it's dominant. After all, recessive lethal alleles could be carried in heterozygous form without any effects, even if fatal in embryo stages, whereas, if Huntingdon's were lethal in embryo stages, you might expect it to gradually disappear from the population as no dominant phenotypes reproduced. So, that's it from me for today. As always, thank you for listening. For any questions, comments, or topic suggestions for future episodes, feel free to get in touch at the show's email address. And until next time, have a great week, everyone.